And we're back with section 3.6. This is problem 7. I've got quite a few chain rule problems floating around on YouTube now, so I highly recommend that you watch each one of them because there are so many applications of the chain rule, and you're really going to need to see a lot of different applications before you're able to solve every chain rule problem. Because, at this point we know the power rule, the product rule, the quotient rule, and now we're learning the chain rule. Well, that doesn't negate these other three rules. It actually works in tandem with them. So every rule and every situation will have a situation where the chain rule is required. So for this problem, we have r equals sine of theta squared times cosine of 2 theta. And I'm going to ask myself, what are the terms that have thetas involved? Well, I have one term here that's sine theta squared, and I have one term here that's cosine of 2 theta. And it's multiplied together, so it's a product. So that tells me I'm going to use the product rule. And this will be my first term, and this will be my second term. And so dr d theta, using the saying that we have for the product rule, we go first, which is sine of theta squared. So first sine of theta squared, d second, that's d theta, times the second, or the second derivative of the second term, which is cosine of 2 theta, plus second, which is cosine of 2 theta, d first, which is the derivative with respect to theta of the first term, which is sine theta squared. And I keep writing the squared on the outside of the sine parentheses, but no, it's inside. So sine parenthesis theta squared in parentheses. So this is our layout. Now we just need to go through and take the derivatives of these terms individually. So right here, the derivative with respect to theta of cosine of 2 theta. Well, according to the chain rule, we always start with the outer function. In this case, it's cosine. The derivative of cosine is negative sine. So we have negative sine, and we leave the inside the same, negative sine of 2 theta. Just like cosine of 2 theta, negative sine 2 theta, leave the inside function alone. But then we're going to multiply the derivative of the inner function on the outside here. And the derivative of 2 theta is just 2. So I'm multiplying 2 onto this. And we still have sine theta squared that's being multiplied into these terms. Well, then we're going to add cosine 2 theta, this term right here, and then we're going to take the derivative with respect to theta of sine of theta squared. Well, the derivative of sine is cosine, so the derivative of the outer function is cosine theta squared, but now we need to multiply that by the derivative of the inner function theta squared. Well, the derivative of theta squared with respect to theta using the power rule is 2 theta. And now we've properly approached this problem using the product rule and the chain rule, and the power rule has popped up too. So all of these are, working together. Now at this point, we're just going to simplify the expression. So dr d theta is equal to, well, we have many different terms here. Here's a minus 2 that we'll put out front. Then we'll have this term sine theta squared times sine of 2 theta, this term right here. Then we're adding 2 theta times cosine of 2 theta having to write pretty small here, times cosine of 2 theta times cosine theta squared. So in my other video, I showed why the chain rule works using what's kind of known as a U substitution. We substitute the inner function, we take the derivative of the outer function multiplied by the derivative of the inner function, and that actually gives us the true derivative of that function with respect to the independent variable. So I highly recommend you check out the other chain rule videos. For this problem, there's so much going on that a U substitution isn't going to help much. You're just going to use the product rule to deal with the outer functions, and then the chain rule to deal with the inner functions. So I hope this was helpful, and I'll see you next video.